Attention car shoppers. Right now at South Carolina Federal Credit Union, you can get a new or used auto loan and pay nothing until 2024, and no payments for 90 days means nothing out of pocket going into the new year. Plus, we have flexible rates and terms, so you could make the best financial choice for you. Learn more at scfederal.org/auto loans. That's scfederal.org/auto loans. Certain restrictions apply. Existing South Carolina Federal credit loans are excluded.
Hello again, and thanks for joining us on Space Nuts, where every week we discuss astronomy, space science, news from around the globe from so many sources. Astronomers, space agencies, scientists, kids at school, they tell us more than we know. Things that have been discovered, things that have been achieved, things that we try to unravel happening in the universe, the great mysteries. So whether you're at home or at work or trucking across the Midwest, relax and spend a little bit of time today with us on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
My name is Andrew Dunkley. I'm your host. So great to be with you. And as always, I'm joined by the good professor himself, Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How are you going there?
I am quite well, sir. How are you?
Yes. Yeah, very good. Thank you.
I'm sure you are, you honorary Dr. You. Tell me what's been going on.
Well, the Macquarie University here in Australia has seen fit to make me an honorary Doctor of Science, which is, that's fabulous.
You get a scalpel with that?
I'm thrilled. Probably. I haven't got the full kit yet. I do have some pieces of paper with some extremely nice words on them, which makes me think that
one of them, a couple of the words, living fossil.
They've written about somebody else, not me. Not living fossil, Andrew. Living legend was what they said.
Right. Okay.
But living fossil is probably just as accurate, if not more so, actually. So yeah, it's fabulous. Look, I'm very honoured. We had a great day yesterday with the graduation, along with I think about 100 other graduates who, because it was just a normal graduation, there weren't as many as they usually have because of COVID-19. But I got to go first, and also to make a speech about inspiration is what I talked about, and the Space Nuts got a mention, so it was all good. Yeah,
fantastic. Well, congratulations, Fred.
Thank you.
That's wonderful, and it's a pity you have to work 150 years to get the recognition.
Right. Well, it takes that long for you to become a fossil. That's it's part of the process.
I thought it'd be 150 million years it'd take.
Yeah, there's that too.
Yeah, and I believe the Vice Chancellor is from Dubbo.
Yes, he is. That's right. Yeah.
How about that? We churn out some pretty intelligent people here.
You do.
Present company on this side of the microphone accepted.
Nice. I've got a very soft spot in my heart for Dubbo because it was the nearest big city for during the 25 years that I lived in Coonabarabran.
Yes, and one of the
Big
brightest in all the wrong ways, light pollution wise. They fixed that though.
Yeah, they're doing well.
Yeah. Right. This week on episode 296 of Space Nuts, we're going to be talking about a discovery, 3 groups of exoplanets forming around a binary star, which, you'd think 1 would be amazing, 2 would be extraordinary, 3 out of this world. Well, it is. It's not here. It's out there somewhere. And I love this story. Despite world tensions, a US astronaut will be hitching a ride home with the Russians. That'll make for some interesting conversation, I imagine. I wonder what they'll talk about. And would you like to add your name to the Artemis mission to the moon? You'll be able to do that. Fred, I've already done it.
Oh, have you?
I have. Yeah, I got a tip-off.
Yeah, well.
From Murray Clare the other day, so I went ahead and did it.
Good on you.
Also today we will be answering some audience questions about harnessing electrons so that we can go anywhere we like in a flash of the mind, apparently. And inertial mass and the elliptic plane versus the orbital plane. We'll be looking at all of those things. Okay, Fred, let's start with the three groups of exoplanets that are forming around a binary star. This sounds like it could be quite rare, or maybe it's not, and we've only just found it for the first time.
Well, that's always the thing, isn't it? You find something in space that we've never seen before, and then suddenly, because you know that such things can exist, suddenly they all turn up. It's a bit like there was the same with fast radio bursts. They were a complete rarity at one stage, and now we detect one a day nearly or something. It's not quite that. So what we've got here is and it kind of follows on a little bit. We talked about protoplanetary disks last week in the fact that a large molecule had been discovered, dimethyl ether. Was that it? Dimethyl ether.
Sounds familiar.
Yeah. The largest molecule discovered to date in a protoplanetary disk. And this story too, whilst it doesn't talk much about molecules, really refers to protoplanetary disks. So if you imagine what happens in the formation of solar systems, very briefly, we've got a cloud of gas and dust. It starts off kind of spherical, but as it collapses, it begins rotating ever more quickly, and that makes it flatten out. And what's in the middle, where the gravitational pull is greatest, the density is greatest, is that kicks off the star. And the rest of it collapses into this debris of material that is quite dusty and from which the planets eventually build up over actually a relatively short period of time, maybe as little as 10 million years, 10 to 100 million years. So, but we know that about half the stars in our galaxy are binary stars. They're twin stars that have formed together from the same cloud of gas and dust. And in fact, it's possible that the sun formed with a partner star, a companion, which has now got lost, our poor long lost sibling.
Typically human, isn't it? We just lose these things. So
You'd never write to me. You'd never write to me. Yes, that's right. Indeed. And so I should just mention, though, that actually the search for sun's lost sibling or siblings is something that is, it's actively being done as part of other surveys. The Gaia survey, the Galar survey, for example, is looking at the detailed chemistry of a million stars. And if something crops up that has got identical chemistry to the sun and is sort of near enough not to have drifted too far away in the sun's 4.57 billion year history, that might be a good candidate for a solar sibling. That's not what this story is about, though. This story is about a binary star, which is two stars forming together. They are rotating around their mutual center of gravity, but each of them have their own protoplanetary disk. Not only that, but the pair of them also has another protoplanetary disk. So what you've got is three protoplanetary disks kind of embedded in one another in this curious object. It's known as SVS 13, nice, easy name. 980.
Which is not a very high standard of sunscreen either.
No, it's not. That's right. Is that SVS or
no, it's
something
it just
else?
Sounded close enough to me.
SPS. Anyway, yeah, you need to get up to 50 for it to be worth anything.
SPF.
SPF, that's it. I knew it was something like that. Some protection factor. How's that?
That's it.
Anyway, this is SVS, and it probably needs a sun protection factor because young stars are pretty intense in ultraviolet light, so you've got a lot of stuff being spitted out. Anyway, 980 light years away within our galaxy, but not one of the nearest stars or nearest pairs of stars, and basically, it's got this really complex distribution of of dust around it, which, as you would immediately guess as soon as we started talking about protoplanetary disks, is being observed by ALMA, the Atacama Large Millimeter Array, which is one of the best telescopes in the world for observing this sort of thing, because warm dust actually emits in the microwave region of the spectrum. So it's great. They've also used actually the National Radio Astronomy Observatory in the USA, their Very Large Array. In fact, I think it's called the Jansky Very Large Array now, named after basically the first radio astronomer. So I think a lot of this, so they had the team that has done this, and I might just mention that they are from the Institute of Astrophysics of Andalusia in Spain and the ALMA Regional Centre, the Atacama Large Millimetre Array Regional Centre, which is at the University of Manchester, which is also where the headquarters of SKA are, big centre for radio astronomy. So there's a group of astronomers who've worked on this, and they have used 30 years of the Very Large Array observations, but they've made new observations with ALMA. And so what they've found is two stars, and I might quote from one of the astronomers who's doing this work, Ana Carla Diaz Rodriguez. I love those Spanish names. I can't pronounce them, but I love them. Yeah. Who says, our results have revealed that each star has a disk of gas and dust around it, and that in addition, a larger disk is forming around both stars. This outer disk shows a spiral structure that is feeding matter into the individual disks, and in all of them, planetary systems could form in the future. This is clear evidence for the presence of disks around both stars and the existence of a common disk in a binary system. So, when you think about that, what it might be like, say, in 100 million years' time, just to cast your mind forward that far, you might wind up with this pair of stars, binary system, each of which has its own family of planets around it. And there's another family of planets that's around the pair of them. It's an extraordinary idea, really, quite an amazing thing. We can say a little bit from their work about the diameter of the disks, and the quotes I've got here, which come from the article that's on Science Alert, nicely written. One has a radius of 12 astronomical units. Remember, an astronomical unit is the distance from the Earth to the Sun. So 12 of them is it's sort of Uranus's distance, if I'm thinking correctly. No, it's a bit less. It's between Saturn and Uranus. The other one's smaller. It's 9 astronomical units. But both of them, that's the dust disks that they've got. Both of them have kind of bigger gas disks of about 30 astronomical units. That's about as far as Neptune is from the Sun. And then this big disk that's around both of them has this sort of spiral structure, which I guess has been imposed on it by the gravitational pull of the two stars spinning around one another. But that goes out to 500 astronomical units. That's, typical of the extreme trans-Neptunian objects that we often talk about in connection with Planet 9. So, very interesting object. Apparently, in visible light, only one of the newly born stars is being seen, which suggests that the other one is still in the process of formation.
So, over time, and as these things develop, is it likely that you will end up with two stars with their individual planets orbiting them and a third set of planets orbiting both? Or is it possible that these things could, develop other ways?
Yeah, I think that's a really good question, Andrew, because, there's a solar system with one star at the middle and the planets going around. It is really stable.
Yep.
But if you drop in another large mass, i.e. another star, even if it brings its own planets with it, you've got gravitational interactions between both of them that could conspire to change things dramatically. But the suggestion coming from this paper seems to be at least that they might very well form in exactly the configuration that you've mentioned. Two stars, each with its own family of planets, and another family belonging to both of them. What you might call an extended family.
Yes, indeed. In the modern era, that probably is normal.
Yeah, it's probably normal. That's right.
Yeah. Wow. No, great work. And as Fred said, you can chase that up if you want to read more about it on the Science Alert website. This is Space Nuts. You're with Andrew Dunkley and Professor Fred Watson.
3, 2, 1.
Space Nuts.
If you would like to help us out, but you don't want to put your hand in your wallet or your purse or whatever it is you carry your notes around in, not that many people do that, or your credit card, you can give us a review if you so desire through your favourite podcast distributor or wherever you access the program, because we'd love for you to pass on your thoughts, good, bad or indifferent. The more reviews, the more aware people will become of us, and therefore we will grow our community and increase our listening audience. So if you could do that for us, that'd be fantastic. So reviews are always welcome if you have time to do that for us, and we thank you in advance. Now, Fred, despite some of the tensions that have been happening in the world in recent times, there's a US astronaut who is due to come home, and he will be hitching a ride with the Russians. This could make for a very interesting flight home, one wonders. Although, as I've said many times before, despite the tensions of the world, the space agencies seem to, find a way around all that. Look, that's for the politicians to decide. We are doing what we all love to do together, despite working for different agencies in different countries. And this is a classic example of it.
That's right, Andrew. There's one caveat, though, to what you've just said, because I think what you've just said is absolutely right. At the level of the individual astronauts and probably their support teams, and probably quite a long way up the chain, the management chain. You've got
I think I know where you're going with this.
Yeah, fantastic cooperation. But it's the person at the head of Roscosmos, the Russian space agency, whose name is Dmitry Rogozin. He is a pretty interesting character and a very strong ally of somebody called Vladimir Putin. So he is somebody who I think has thrown many spanners into the works in terms of this cooperation.
Yeah. Well, didn't they recently cancel was it a UK launch that they were supposed to? Yeah.
In fact, they've not just cancelled the launch. This was I think it was going to be a Soyuz launch of 36 OneWeb satellites. OneWeb is one of the two main satellite constellations that we're seeing in the skies at the moment, the other being Starlink, of course. I think OneWeb's got about 380 spacecraft out of, is it 300? It's about 300 anyway. I think 600 or 680, I can't remember the exact number, which are planned for the OneWeb constellation. So they were about halfway there, and their contracts are with this Roscosmos to launch the remaining ones, and they had 36 all set to go, which I think have been basically commandeered by the Russians, unless OneWeb. I forgot what it is. Yes, they've got to make OneWeb has got to make the British or demonstrate that nothing that they do will be to do with defence, which they can't do.
Yeah,
and that's the only way they'll get them back. And so it's things like that are being stirred up from on high. Plus the comment that Rogozin made it's probably about 6 months ago, which we discussed about the idea of Russia building its own space station and pulling out of the ISS in, I think, 2024. I think that's the date that they've threatened, even though the remaining four partners of the ISS want to keep it going until, I think, 2030. That's the current sort of end date, thereabouts. Anyway, in the middle of all this, we have a situation where it's all about the schedules, Andrew, who's scheduled to do what. And so I think it's this week. It may be next week, March 30th. I beg your pardon. It's the end of the month. It's Mark van der Hey. I hope I'm pronouncing his name correctly. It could be Van der Hei, but it's HEI. He's the US astronaut who is scheduled on the 30th of March to come down with his two Russian cosmonaut colleagues. Now, he's actually he's broken a record, or he will have done by then, 355 days in space, which is the highest number for any US astronaut.
Wow, I can't imagine being up there for that long.
10 days short of a year, yeah.
I went nuts after 2 weeks in isolation at home.
Yes.
and they've probably got less room than I've got here.
Oh, yeah, they definitely do. That's right.
Gosh, I don't know. How would your day go? What would you do?
You know, I think what would happen is kind of what happened to a lot of us in lockdown. You just live one day, can't take it one day at a time.
Yeah.
And by the end of it, you realise that you've lost a year, which certainly that's the way I feel about 2021 and most of 2020.
Yeah, well, I've got to admit that even though, because of the strangeness of these last couple of years, we are now looking back going, where did that time go? What happened? Yeah. It just flashed by.
That's right. It's really interesting. Exactly.
So it's the same on a space capsule, okay?
I'm sure that's right. Yeah. So, I suspect that the guys at the moment, the crew is 2 Russians, 4 US astronauts, and I think 1 German astronaut up there. There's 7 people aboard at the moment. So 2 Russians plus Mark van der Hei coming back on the 30th of March. Now, they've been working together for years, but it probably is years, actually, because they've done all the training together. I think it is a really tight group of people, the combined cosmonaut-astronaut club, as it were, because they've got to train together and they do so much together. They've got to get on, and they do. So they I think, are pretty well adjusted with one another. But of course, the way things have developed over the last 3 weeks is bound to put a strain. Someone made a comment, and I can't remember whether it was Mark himself. Yes, it was Mark, who made the comment to a TV interview last month. We haven't talked about it too much. I'm not sure we really want to go there. Yes. So I think, they'll just stay away from the topic and work on what they're doing and do well at that. But it's a really interesting business. There's a kind of nice comment from a person who was a NASA astronaut, whose father was born in Ukraine. Her name is Heide Maria Stefanshin Piper, and she says, we're sanctioning Russia. Companies are pulling out of doing business in Russia, but then yet you still have the US government, the space agency, doing business with the Russians. You can't push a button and separate the two sides of the space station, and that's exactly it. It's intimately linked. So, I think it will be fabulous if, when it all settles down, there's still good cooperation between the Roscosmos and NASA in space. As we said at the outset, though, the fly in the ointment is the head of the space.
Are we at this stage doubting that he'll be allowed to come home with them, or are they going to follow through on it?
No, I think it'll just happen. I think it'll happen as scheduled. There'll be an aircraft, a NASA aircraft, waiting for him essentially when they touch down, and that'll whiz him back to Houston. It's likely just to go down as a normal scheduled thing. They land in Kazakhstan, which is the normal landing place for cosmonauts. He'll get picked up and debriefed on the way and all the rest of it.
Yes. Well, interesting times is basically where we're at. When it comes to the International Space Station, is it classified as like neutral territory?
I guess so, although it's got, Russian segments and American segments. And I think we discussed at some time in the recent weeks that one of the toilets had broken down, so they had to use the toilet in the other one. So yeah, I look. It's
That's why
but
the
I don't
French.
think
That's why the French can't be there, Fred, because they wanted a bidet, and that would have caused all sorts of problems.
Yeah, that's probably right. The French, of course, are there represented by the European Space Agency, which is one of the space agencies. But anyway, I think the space station is counted as neutral territory because they've got to be able to access all of it. You know how they all climb into hardened parts of it, usually the Soyuz escape spacecraft, when there's a threat of a collision impact of some sort,
right.
a piece of debris.
Yep.
So they're all in it together. They're in such a dangerous and fragile environment that it's the only way to survive. You've got to club together. You've got to be resourceful and mutually dependent on each other.
Yeah, and all credit to them. And what an amazing thing! 355 days. Wow. Couldn't he afford 10 more? That would have been a year.
Yeah, that's right. It's he's already broken the record. In fact, I think that's why, which was 340 days for a US single space flight.
All right, we wish him well and safe trip home. While we're talking about travelling in space, you and I can go to the moon.
Well, go around the moon anyway.
We can go around the moon on the Artemis mission because they are offering people the opportunity to submit their names to be included on a flash drive that will be sent on Artemis 1. And I'm going to show you mine. Fred, look.
Oh, let's have a look.
There's my pass on the Artemis mission.
Hang on. All I've got at the moment is a where's
I'll put it up there.
Yeah, there it is. Oh, fabulous. That's right. It's better than what I was looking at, which was a piece of salmon. So I don't know quite how that got there. But
yes, I think this is a great idea. It sort of gets the public involved and sort of ignites a bit more interest in the project.
Yes, it's actually quite a common thing to gather names to send to space. One of the classic ones I remember was now what's his name? The hotel chain owner in the USA who also has deployed inflatable modules. It'll come to me in a minute.
Hilton?
No, it's not. It's not Hilton. It's a good try. It's inflatable modules, one of which is actually attached to the space station to trial it. So these are capsules that are basically blow up, balloons, except they've got many, many, many layers. And they have a project called Genesis, and I think these two, the Genesis 1 and Genesis 2 spacecraft, are still in orbit. But Genesis 2, when it flew, had not only the names of, but also photographs of, I think it was thousands of people. I can't remember how many it was who, they had a picture with their name on the back. And we had video footage from the inside of this inflatable capsule once it had inflated, with all these photographs of people floating around in zero gravity.
Was it Robert Bigelow?
Bigelow, that's right. Exactly right.
Yeah.
Thank you. Bigelow Space. It's a common thing to do, but it's very nice to have something historic like this happening, because actually Artemis 1 will use the Space Launch System for the first time. That's the thing that NASA has developed from using actually basically the Space Shuttle mission boosters, Space Shuttle style boosters to the chemical rockets to act as boosters on it.
Yeah. Well, if you would like to get your name added to the flash drive and do a lap around the moon on Artemis 1, you just need to go to the NASA website. In fact, probably easier to just do a search for Artemis 1 Get Boarding Pass.
That's it, yeah.
And you should be able to find it. It's an easy link. Actually, I might see if Hugh can put the link on our show notes. But it's nasa.gov/send-your-name-with-Artemis. That's not too hard to remember.
No, not really, no.
But, that should be a lot of fun. When's that mission due, did we say?
It is sometime I think it's next year or 2004.
Yeah.
Let me just see. Sorry, 2024, not 2004. That's gone now, Fred. That's gone. Just trying to remind myself. No, I beg your pardon. It's this year. I'm sorry.
May, June, maybe July.
I'm confusing it. That's right. May, June, and July. Confusing it with other missions.
Okay. Well, that's how you do it. And
so probably get your name down pretty soon, I would guess.
Yeah, I wouldn't waste any time on that for sure. You're going to do yours, Fred?
I'll give it a try. Yeah.
All right. We might get seats next to each other. Oh no, hang on. You'll be in first class.
No, well, look, I'll be in steerage class because it'll be in alphabetical order, and W is a lot further down the pecking order than D. So
I was hoping they'd go with Christian names. Then I'd be in first class.
You'd be first class. Yeah, that's right.
For sure.
Yeah.
All right. Check that one out at the NASA website. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Now, if you're a social media user, you will find us on Facebook. We've got an official Space Nuts page there. We also have the Space Nuts podcast group, which was created by Space Nuts listeners, and it's where you can get together with like-minded people and talk about astronomy and space science. You can also share pictures. And we get a lot of astrophotographers, backyard astronomers who show us their pictures. So it is really a great fun page, the Space Nuts podcast group. We're on Instagram as well. We're not on TikTok. And I'm wondering why, but I'm in no hurry. There's only so much you can do. But we're on Twitter as well. So if you would like to follow us on any of those entities, you can do so. And, of course, YouTube, where you can see video editions of the show. Why on God's green earth you would want to look at us, I still haven't figured out the answer to that, but you can do so. Now, Fred, time to try and tackle some audience questions, and we are going to start with Mikey, who's in Illinois.
Hey, Andrew. Hey, Professor Watson. This is Mikey from Illinois in the U.S., so I've got kind of an out there type of question for you guys. It's been on my mind for a little while now. And it's not about black holes, so that should be reassuring. I was listening to an episode of Star Talk with Neil deGrasse Tyson a few weeks ago, and in it he had mentioned that all electrons are exactly the same, thus explaining how we can send a message from New York to LA instantaneously without the message having to actually travel the physical distance. And so if I'm understanding that correctly, does that mean that if we were to somehow harness all the electrons in our bodies, we could beam ourselves instantaneously around the globe and possibly one day around the universe? And kind of dovetailing off that, does each individual person have their own specific amount of electrons that makes that person unique, or do we all, give or take, have the same amount of electrons in our bodies? Sorry if that was a lot or if it doesn't make much sense. Thanks for doing what you guys do. I'm constantly looking forward to new episodes. Helps me get through work, and I love it. You guys are one of the two podcasts that I'll forever be faithful to. Thanks.
Thanks, Mikey. Lovely to hear from you. We don't get many particle physics questions, Fred.
No, we don't. It's a really interesting question, and I think it might be a quantum mechanics question, really. Because
now you're splitting hairs.
Yeah. So I'd be able to answer this more cogently if I'd heard the original comment from Neil deGrasse Tyson. It's true that all electrons are identical because they are truly fundamental particles. They're one of the 16 fundamental particles that make up the contents of the universe. And you can't split them into other things. That's the point. You can't bash them with other electrons or protons or whatever, but they still stay electrons. But the idea of transmitting them instantaneously is, I think there's a bit of confusion coming here with the idea of entanglement. If you've got two electrons entangled and you take one of them a long way away and you do something to one of them, then the other one reacts. That's the thing about entanglement. And it's weird because it seems to defy relativity, that nothing can travel faster than the speed of light. But in fact, it doesn't defy that relativity. I've heard explanations that really put it into perspective, that what we're not seeing is information being transmitted at faster than the speed of light. We're just seeing something more relating to coincidence, the fact that you've got, what is in one. If they're entangled, you find out what's in one, so you know what's in the other. It's that kind of thing. Anyway, if you want to send signals from one set of electrons, for example, me sitting in New York or sitting in Sydney, to another set of electrons, for example, you sitting in LA or more likely in Dubbo, you've got to use an intermediary, which is the photon, and the photon travels at the speed of photons, the speed of light, no matter whether it's a radio wave or a photon. So there isn't really any future in trying to envisage, if we were somehow made of, well, even entangled electrons, we still would not be able to zip around the universe. We wouldn't really have any advantage over the situation that exists now, that physics says that nothing can travel through space faster than the speed of light. And that's what stuffs us up in terms of interstellar space. So it's a nice idea, Mikey, and I like your thinking. Because it got me thinking as well, and that's always a good thing.
Yes.
But I think the answer is no.
Aha. All right. Which is a pity. It would have been nice to have a workable theory on that. But
yes.
until
better than wormhole.
Yeah, until we can create wormholes or fold space,
that's right.
We're stuck with the speed of light, which we cannot attain at this point in time, and may never be able to. Although we'll be able to get pretty far down the road.
Yeah, it's the fact that the energy that you need to accelerate anything to the speed of light just goes up completely exponentially. Yeah. And as you get close to the speed of light, you have to put more energy in, and that's why it's an impossible barrier, because the theory is quite clear that an object other than a photon, which effectively is massless, but an object accelerated to the speed of light would need infinite energy, and we haven't got that yet.
Yeah. Okay. It's I equate it to paying off a mortgage. It's the same.
Same thing.
It's the same steep curve.
Yeah, that's right.
Takes a long time.
Yes.
Thanks, Mikey. All right. Our next question comes from Jerry.
Hello, Professor Fred Watson and Andrew Dunkley. This is Jerry from South Dakota, USA. I'm a longtime listener to your show, and you guys are always doing some great things. I have a couple curious questions to ask you fine gentlemen. I was recently reading an article where Einstein used relativity to show that as you approach the speed of light, time goes slower. Space contracts, and you then get heavier. Basically, the faster you move, the heavier you get. This means mass is just kind of locked up energy, which, if I remember correctly, is called inertial mass or gravitational mass. So my first question is, how accurately can we measure inertial mass? And my follow-up is, instead of the elliptic plane of our solar system and the galactic plane of our Milky Way being inclined to each other at, if I remember correctly, an angle of 60-some degrees, if our elliptic plane and galactic plane were perfectly aligned, would we be able to detect the change in our inertial mass as we orbit with and against the spin of our own galaxy? And if in the future, if we could use those measurements as an indicator of the direction we are traveling in the greater universe? Thank you for your time to answer my nutty questions.
Yeah, thanks for the question. That's another thought-provoking concept. Thanks, Jerry. We'll start with the question of inertial mass.
Yeah. So just one clarification is that the time dilation and what's called a Lorentz-Fitzgerald contraction, which is the warping of space, and the increase in mass as an object approaches the speed of light, they are as observed by an external observer. So for the person who's traveling at the speed of light, the clock ticks at the same rate, your length doesn't change, and your mass doesn't change. It's all about the reference systems between the two.
Yeah.
Now, the inertial mass and gravitational mass are the two things that Einstein had the greatest thought of his life, as he described it, in 1907, if I remember rightly. This occurred to him that the inertial mass, which is the resistance of an object to acceleration, if I can put it that way, is equivalent to its gravitational mass, which is the way it behaves in a gravitational field. Those two things are equivalent, and it's actually known as the equivalence principle, which was, I think, fully formulated in 1912, if I remember rightly. I can't remember the history here, but it's looking for that difference between the inertial mass and the gravitational mass. That is one of the ways in which physicists are trying to prove, trying to look for holes in relativity. You know, you and I have talked about looking at the way things behave in intense gravitational fields, looking for holes in relativity. But this idea of trying to measure any difference between inertial mass and gravitational mass, which is done in many different ways. You can do it with balances, even looking at the way gravitational pulls something in a balance and comparing that with its inertial mass.
Refer to previous comment about mortgages.
Exactly. Balance comes into it. Yeah. That's the bit that always goes to infinity. Yeah. It looks like infinity from where most of us are standing, I have to say, in terms of mortgages. But what I was going to say was there are other ways of exploring the relationship between inertial mass and gravitational mass. And they do involve motion. They involve spacecraft in orbit around the Earth. Now, I haven't looked at this for many, many years. So it might be the kind of thing that Jerry's talking about in terms of, you know, how you would detect the difference between the inertial mass when you're orbiting the Earth. It doesn't actually matter that the Earth is not parallel to the plane of the Earth's orbit. The ecliptic is not parallel to the plane of the sun's orbit around the galaxy, which is the plane of the Milky Way. Because you could still do it. You could take a factor into consideration. But I think the answer is no, basically. And I'm not quite sure what you would be aiming for. I think Jerry mentioned the sort of absolute speed of the solar system relative to the universe as a whole. That might be the kind of thing he was thinking of. And there's a different way of doing that. And that is to look at, we can look at the sun's motion relative to the cosmic microwave background radiation, which is the oldest thing we can see. And it might not correspond necessarily with the inertial reference frame of the universe, but it is something like that. And we have a motion, if I remember rightly, it's in the region of 300 kilometers per second relative to that. And you can detect that by looking at the average temperature, color temperature on one side of the sky compared with the other side on the cosmic microwave background radiation. So there are ways of doing the kind of thing that I think Jerry is getting at, but probably looking at inertial mass and gravitational mass are not really the way to do it.
Is this something that the James Webb Space Telescope might be able to investigate?
Probably not, no, because I think you want to be looking, they're going to look back to the earliest history of the universe, other than the cosmic microwave background radiation, which is the farthest thing we can see, and we can already see that. And a lot has been learned from that. There are specialist telescopes that do this, and there have been 3 orbiting telescopes which have done it. Hubble in the 1990s, WMAP in the early 2000s, and Planck in the late 2010s, I think. Those spacecraft have all mapped the cosmological background radiation. And that's the kind of thing you need to look at to glean the information, the sort of information that we're talking about. Okay.
Hopefully we helped, Jerry. If you want to send a follow-up question, we might be able to add a bit more to it. But it's a bit beyond my brain, I'm afraid.
The great thing about questions like this is that they get you thinking.
Oh,
yes. It's fantastic that our listeners can do that, can send our minds wandering in directions that they haven't been before.
Yeah, absolutely true. Yeah, and keep those cards and letters coming in via our website, spacenutspodcast.com or spacenuts.io. There's a couple of ways you can send us questions. You can record it and tell us who you are and where you're from, or you can send us a text question on the AMA tab. So we look forward to getting them, and hopefully we'll be able to answer all of them. Sometimes they're sometimes they're cheeky, sometimes they're just a little bit complex, but we try our best. Well, I don't. Fred does, but I don't try at all. I just pick it up as I go along.
You do.
I've got a more Monty Python-esque approach to the way these things are done. But yes, that's where you go. And while you're at the website, you can certainly check out our shop. It's pretty easy to find, spacenutspodcast.com, as I said, and then just click on the shop tab, which is very convenient, where you might find a shop. And if you've got someone that's hard to buy for and you think, oh, what could I get them? We have adequate gifts at the Space Nuts shop. So that's something to think about.
Adequate. Just like the podcast.
Yes. Yes, we don't strive to be elite or superior or, better than anyone else. We just want to be adequate. Haven't used that for a while.
It's only adequate because it's there. That's the only thing that
All right. That brings us to the end of another program. Fred, thank you so much.
Great pleasure, Andrew. Always good to get the old brain cells working and think about these different things.
Given that I was up at 3:45 this morning, my brain cells at this time of the afternoon are really struggling. So
I bet they are, yeah. You're doing a great job.
As we move ever closer to episode 300, still working on plans. So we'll let you know when we get a bit closer, but we've got a couple of ideas. Fred, thank you. We'll see you soon.
Sounds great. Take care, Andrew.
You too. Fred Watson, astronomer at large and now an honorary doctor. Woohoo! And from me, Andrew Dunkley, who's not an honorary anything, thanks for your company, and we'll catch you again on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.